Welcome back to Concepts in Arithmetic. We are moving on to the subtraction algorithm in this video. Now, like the addition algorithm, this would be taught in stages in the primary grades. And stage one would be problems that involve no rebundling. So, in this case, the ones, tens, hundreds, etc. can be subtracted individually. So, for example, a problem like 58 minus 36. If we were to use the chip model, we can get our trays here. So I would load in the 58, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. So I start by loading in the 58, and then in each place I start crossing out the number of chips determined by this number down here, determined by the subtrahend, if you remember the vocab from chapter 1. Okay, so I got 8 chips in the ones tray, and I'm going to cross out 6. So let's just put a slash through 1, 2, 3, 4, 5, 6. And here in the tens tray, I've got 5. I'm going to slash out 1, 2, 3. And we can see I'm left with 22. Okay, so remember, the chip model is supposed to show us how we're getting the answer. Okay, so this is the first stage that we would work with students on using the subtraction algorithm. And remember, the goal is we start out with the chip model, but we want to get them to using numbers only. So second stage, we would introduce unbundling, or goes by a few different names depending on the resources that you're using. Could be called decomposing a 10, could be called regrouping. When I learned it, it was called borrowing. Okay, so something like this. Let's do 76 minus 29. Okay, so once again, we will begin by loading in this number. So we always start with our chip model by loading in the minuend, if you remember your chapter 1 vocabulary. In this case, it's 76. Okay, so 1, 2, 3, 4, 5, 6, 7 in the tens tray. And then in the ones tray, 1, 2, 3, 4, 5, 6. All right, so we look at the ones tray, and we see we've got 6 chips in there. We got to take away 9. Okay, so we can't take away 9, or we can't cross out 9, so here's what we do. We take one of these, and we decompose it. So that single tens chip would give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here. Okay? And now we can take away 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 are now gone. And now over here, we'll go to the tens tray. We started with 7, now we only have 6 because we unbundled one of those, and we got to take away 2. We still have to do that operation, so we take away 2. All right, now, let's think about how we record this over here. So we looked at that. We have 6 in the ones tray, we have to take away 9. Can't do it. So we unbundle, leaving us with 6 in the tens tray and 16 chips in the ones tray. Now that we have 16, we can take away 9. 16 take away 9 leaves us with 1, 2, 3, 4, 5, 6, 7 chips. And from the 6 remaining chips that we had in the tens tray, we take away 2, leaving us with 4. So 47. Okay, so we always start by loading in the minuend in the tray. And we're going to start crossing out based on the subtrahend. Okay, so in this case, the minuend was 76, the subtrahend was 29. And we get a difference of 47. Okay, we're going to unbundle as needed. Okay, so any subtraction algorithm is going to hinge on the process of students being able to rebundle, trade in a tens chip for 10 ones chips, or trade in a hundreds chip for 10 tens chips. So they need to know how to do that. They need to know that part of the place value process. And they also need to know how to do the stage 1 problems. Okay. Now, I'm going to include one more stage for this, because this is something that doesn't really come up when students are doing addition problems. It can come up when we're doing subtraction problems. Once we get to 3-digit problems, let's say we had something like this. Let's say we do, okay, how about 503 minus 267? Okay, 503 minus 267. So this is the hardest kind of problem for students to get, in my experience, because we have to rebundle through a 0. Okay, so we're going to need 3 trays here if we're going to do a chip model. So we have a hundreds tray, we have a tens tray, and we have a ones. So we start by loading in this top number here, right, which we were calling the subtrahend. 1, 2, 3, 4, 5. So we have 500, no tens, and then 3 ones. 1, 2, 3. Okay, now we're supposed to start crossing out. Okay, so we're supposed to cross out 7 in the ones tray. Well, we don't have any, or we don't have enough, rather. I can't cross out 7 because I only got 3. Okay, well, under normal circumstances, we would go to the tens tray and unbundle one of those tens. But there's nothing here either. So we got to go over one more. So we're unbundling 100, which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the tens tray. And now I take out one of those, and now I can unbundle and get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I have enough items in the tens tray to cross out 7. So take 1, 2, 3, 4, 5, 6, 7. And now here I'm supposed to cross out 6. 1, 2, 3, 4, 5, 6. And finally, cross out 2 in the hundreds tray. All right, now let's kind of transfer the work that we did in the chip model over to this here. Okay, so we said, okay, we got 3, we're taking away 7. All right, we're going to have to unbundle something from here, but there's nothing here. So we unbundled from here. We were left with 4 tens. Remember, we had these 3 right here. We were left with 4 tens. And that gave us 10 in the tens place. Now we unbundled one of those, and we only had 9, till we finally ended up with 13 in the ones place. 13, we can take away 7, leave us with 6. 9, take away 6, left us with 1, 2, 3. And then 4, cross out 2, and we were left with 2. So the resulting 236. So once again, this is probably the hardest type of problem, because we had to go over through a tray that was completely empty. Unbundle here and then unbundle again, and that was all just to get this one place dealt with. Okay. So here's one thing to note here. You might think, well, one of the things that the students need to know is they need to know two-digit subtraction. You need to know 13 minus 6. And that's true, yet it'd be nice for the students to do it that way. But I'm sure you've seen something like this here. So let's look at an alternative algorithm. Which involves just subtracting from 10. Okay, so you might have seen this here. Okay, a student is trying to do 18 minus 9. And they say, okay, 8 take away 9. Well, I can't do that, so I borrow from this, and I have 18 minus 9. So the algorithm means he has to know 18 minus 9. And with the standard way of doing the algorithm, you have to know subtraction within 20. Okay, but you really don't, because you can do it this way. So let's just look at that 18 minus 9 there. It's a little bit of a silly example, but so if we start with 1 and then 1, 2, 3, 4, 5, 6, 7, 8, we would unbundle that and give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down here. So what you do is you look here. You don't look at the entire tray, you just look at the 10s that you just made. And of course we know what 10 take away 9 is. That would leave us with just 1. Okay, so 10 take away 9, and you're left with 9. All right, let me do a few of those here, a couple of examples of using that alternative algorithm. Let's do something like 61 minus 37. Okay, so I'm not going to go to the chip model here. Remember, the whole point is to get the students to transition to just working with the numbers only. And on your homework assignment, don't draw out the chip model unless the instructions explicitly say to draw out the chip model. Okay, so 61 minus 37, so we unbundle, we're left with 5. So instead of thinking of it as 11 and having to know 11 minus 7, what we could do is think of it as 10 and then one more. 10 minus 7 is 3, and then 5 minus 3 is 2 to get 23. Okay, let's look at one where we have to kind of carry through. 406 minus 139. Okay, so we got 6, we're subtracting 9, can't do it. Can't unbundle anything, so we'll have 3. Got to unbundle from there. 10 take away 9 is 1. We had 6 there, so that's 7. 9 minus 3 is 6. So we have 267. Okay? So the students really don't need subtraction within 20. They just need to be able to work out their 10's complement. Okay, 10 take away 9 is what we really need to know. We don't really need 16 take away 9. Okay, so make sure that when you're going through the teaching sequence, you do include some word problems that would get the students extra practice with the algorithm. Okay, so let's just do a quick example here. So, an example word problem. Let's say Mr. Smith earns $3,265 and spends $2,955. We'll ask how much does he have left? Okay, so he earns $3,265, spends $2,955. How much does he have left? Let's write out our teacher's solution. So remember, what we want to see is a bar diagram, a computation, and a sentence. So this bar is going to represent how much he earned, and that's 3,265. We'll have a second bar right underneath it indicating how much he spent, 2,955. So the question we're trying to answer is, how long is that little piece right there? Okay, what's the overlap? And of course, we answer that question by doing a subtraction. Okay, so 0, 1, 2 minus 9 can't do it, so we unbundle. We have 12, so that we leave us with 3. So that's the answer to the subtraction. Now remember, in a teacher's solution, we're expecting a sentence. So we'll say Mr. Smith has $310 left. Okay. So using the algorithm to help us solve a word problem right there. That is not something we would do mentally. We'll write it out.